So today let's continue working on the Tektronix oscilloscope from the previous episode. It's a 500 MHz 4-channel digital oscilloscope. It has a monochrome CRT and a liquid crystal color shutter, which is supposed to give it color, but it's not working. And I want to check the voltages on the color shutter, but how am I supposed to get to the terminals of it? The cable from it goes to the connector in the CRT board, but there is no way of accessing it when it's running. Because to run it I have to have everything connected, and to have everything connected, these boards here have to be in their place. This thing's really not easy to work on. But at least I figured out this panel can actually be popped out. It just pushes in and it has this cable and a ground cable. Here are all the potentiometers, or actually some rotary encoders. These boards have to go and everything has to be disconnected, and this cover has to go, and only then I can access this connector going into the color filter. How am I bloody supposed to take measurements on this when it's running? But anyway, let's just take a closer look inside of this for the curious ones. Here the mains comes in here, some interference suppression, the fuse holder, the switch, a lot of interference suppression here, inductors, capacitors. I was thinking this is the power transformer, but it's probably just another interference suppression. Here's the control board of the power supply, the main smoothing capacitor after this bridge rectifier. Is this interference suppression, and here's a big film capacitor which might suggest it's a half bridge. And there is a thermal fuse, a reversible bimetal thermal fuse against overheating, and some transistors on this heatsink, danger of course, some current sensing transformer here, the main transformer, a lot of output inductors, which of course suggest it's not a flyback, and a lot of rectifying diodes here. I guess this has multiple outputs. So this is basically a multiple output switching power supply, probably a half bridge with the main power supply here, the main transformer, maybe the base driving transformer for the transistors. And is this an auxiliary transformer? It can be switched into standby, so maybe this is an auxiliary power supply. And here's another control board with a lot of chips and a lot of components on it. And here's the CRT section. Of course the multiplier or some resistive divider, and the flyback transformer under it with its ferrite core. And in the CRT section there is a lot of potentiometers for adjustments, but I'm not sure how you're supposed to adjust these. This is covered by the metal case and all the boards above it. I guess they're adjusting the monitor completely separately using some test pattern generator and some test power supply. They are not adjusting it inside of this. Danger high voltage. Corona OK. Imagine that. At least nothing to catch here, but how am I supposed to work on this? I guess they were just replacing the entire monitor assembly when it failed, and nobody was fixing it on a component level. I guess I could just give up and remove the color filter immediately without looking for the problem. Or as the last resort, I can actually try to assemble it with the CRT sticking out and poke into these cables through the insulation. But anyway, this channel is about learning something instead of just blindly fixing something, so I'm putting this plastic bag under the CRT board so it doesn't short to something here. The CRT will be operated, sticking out, and I will try to measure the waveforms on this, because blindly removing the color filter would be like amputating your hand or leg without even knowing it's bad or not. I'd rather die than having something amputated, so let's treat this oscilloscope with the same approach. Let's try to save this sorting limb. An oscilloscope to fix an oscilloscope, interesting. And I have this probe, not sure what voltages to expect, but I guess just a couple of volts. But anyway, let's use a 100 times probe just to be safe. It has a convenient sharp tip on it. I guess now with the CRT out, this has to be externally grounded. This can go back in. Let's ground the oscilloscope conveniently on this broken screw here, for example. It's running, there's a picture on the CRT, but of course bloody damn. And of course this thing always forgets the probe attenuation setting and switches back to ×1. And this is dodgy, but let's poke through the cable insulation into the wires and see the waveforms here. There is actually in a total 12 wires, 2 cables, 6 wires each. Or is it such a low voltage? Second wire, nothing, nothing. Are you kidding me? Of course I'm staggering the holes, I'm not making 2 holes right next to each other. Nothing. There's nothing in the cable, at least nothing in reference to the ground. Is the oscilloscope even working? Well, let's poke it somewhere. This is a 5V rail, I guess. And it's showing a 2.5 division reading, of course, because it's 2 volts per division. There's a little bit of a noise, but really nothing like a periodic signal. Let's try different time bases. A little bit of noise maybe, but really nothing like a 60 Hz signal or anything. I'd expect some 60 Hz square wave or something here. Okay, a times 10 probe and 50 millivolts per division, and virtually all wires seem to have the same thing on them. Some noise, but nothing periodic here. Whatever that is. A noise. Or maybe there's the signal which is not referenced to the chassis. It might be isolated somehow. Okay, let's probe a random combination of two different wires instead of referencing the ground of the oscilloscope to the ground of the other oscilloscope, and I sort of thought I'm measuring something, but this is minus ripple when the ground of the clip is not connected. Now actually probing between two wires and nothing. I'm actually not sure why did I do it, but I took the entire monitor assembly out of it. The CRT board and the CRT. I might actually check the ESR of the capacitors when it's already out. And this is the connector from the color shutter which went into here. There is basically an additional board on this monitor board which does the color switching, I guess. This board is connected to the main board using these 4 pins and one pin here. And one is actually cut here. Not sure, is this from a manufacturer? Did somebody cut it on purpose? Did somebody cut it to disable the color shutter? Maybe somebody was already trying to fix it and gave up and basically disabled the color switching by cutting the supply voltage to this? Or was this made like this? And some of the date codes say 98 on this thing, and on the CRT I guess it was already changed at some point. Or maybe even later. 110305 or 95. It's weird. The CRT was probably changed. Is this from 2005? A lot of components here date coded 98. And the high voltage transformer 99. And I also like how on this power supply board these two resistors are actually crossed. Some board designing a bad day. I checked the ESR of all electrolytic capacitors in this monitor board. All of them have the ESR appropriate for their sizes or capacitances. There are of course tables for typical ESR values of various capacitances of capacitors. This board from the top has a lot of small electrolytic capacitors. All of them are about 1 ohm, which is okay for small electrolytic capacitors. These are 10 micro or 3.3 micro. On the big board, some capacitors have such low ESR it's suspicious. It almost looks like they're shorted, because these very small 10 micro or 33 micro electrolytic capacitors typically have a higher ESR. But the thing is, there is a lot of them parallel on one rail, and they also have some ceramic ones in parallel, and that's why the ESR is so low. Checking negative to negative, positive to positive. There's a lot of them on one rail, on probably the 5V rail in parallel. There are some which are 8 ohms, which for a 33 micro capacitor is sort of crappy. 33 micro 10 volts. It should be between 22 and 47. It should be something between 2.2 and 5.4 ohms. In the worst case. Is this what actually makes the color not work? I took one out, verifying out of the circuit. It's 8 ohms ESR, which is quite high for 33 micro. A good low ESR one, 0.26 ohms. This is 30 times less. Let's just botch replace it using whatever tools I have, whatever spare components I have. Some of you are probably now screaming in horror. And that's it. A little bit of post-apocalyptic capacitor changing here. I took out another. This one is 11 ohms, even worse. It seems the 3.3 and 10 micro ones were good, as the 33 micro ones were a bad batch. 3.3 micro is 1.8 ohms, the 10 micro is 0.35 ohms, and ESR should go down with more capacitance, but the 33 micro is over 10 ohms. Horrible. The smaller board has just 3.3 and 10 micro ones, so I'm not touching this board, but the bigger board is full of these 33 micro crappy ones. I'm changing these capacitors, and some of these are near this chip, which says video, and the connectors from here go to the monitor board. So maybe this could cause the color problems. One more from the vicinity of the video chip over 12 ohms, but it still shows the right capacitance. And this one actually read fraction of an ohm in the board, because it's parallel to something. In reality 12 ohms. which basically means I can change all of them here. At least the board with the inputs on it doesn't seem to have any electrolytic capacitors. I cleaned the one, but it doesn't matter, I can just leave the buckets of rosin on it. All 19 capacitors changed here. The worst one is 17 ohms. And now the power supply board comes out. A lot of screws going through it into the bottom and 2 screws going into this box from the back. And then it comes out. And we're left with just a bare box. So that's the power supply board, no components on the other side of it. Now let's of course check the ESR of all capacitors in it, all the electrolytic ones. Of course checking the main primary smoothing capacitor for a charge. About 0.1 ohm, it's a big capacitor. Tiny 47 microcapacitor is about 0.3 ohms, nice. Most of them have quite a low ESR. And this 47 micro 80 volt capacitor is sort of on the threshold. In a switching power supply you typically want to have low ESR capacitors. I have 47 micro 100 volts. And its ESR is about 1/5 of it. This one is probably not completely bad, but it has a question mark, and when I have it opened, let's replace it. One more slightly questionable, preventively changed. 100 micro, 100 milliohms, nice. 2700 micro, 10 volts, just a couple milliohms, just like the other ones. Nice. Some 680 micro capacitors. Some tiny capacitors here, about 2 ohms, but it's just 10 micro, so it's acceptable. Why the other identical 10 micro capacitor is 4 ohms? Preventively changed, the new ones are 1.5 ohms. Okay, 3 capacitors changed. And now the more interesting part. What's this burn mark here? What the hell happened to the circuit board? It's not the traces, it's the gap between them. Was it actually burning on the other side? It's under these big capacitors. It seems I have to desolder these two to see the board. There's probably a burned trace. Now, is this carnage from an overloaded trace on the board, or were the capacitors burning, or were they leaking and causing a short, or the electrolyte basically dissolving the board? It looks burned, not just dissolved. Especially this capacitor looks. It probably leaked here. Of course it shows low ESR on an ESR meter, but when it's leaking electrolyte it doesn't necessarily have to mean the ESR is going to be high. And that's quite a disaster here. One more capacitor removed to see the board. It's probably fixable. This trace has to be removed and replaced with a wire. I removed the part of the board which the electrolyte probably made conductive. This wire goes here. Things always look like an easy quick fix and then turn into a bloody nightmare. This capacitor is going to be replaced with this one. And these 2700 microcapacitors, such a weird value. It's in total 5400. I could just put this capacitor for both or add this one to get it closer. It's just all in parallel and it's a power supply rail, it's not critical. The important thing is they have to be a low ESR type. Now the capacitors are in it. The power supply board is back. Let's take a look at this one. Why this pin is cut here? Is it actually bridged to something else? It's actually bridged here, but not on this side. And it's actually the 0 volt rail. And the weirdest thing is that when I bridge these two holes, then it actually is bridged. So the metal chassis is the only interconnection between these things. And this actually means when it's in the chassis, the connection jumps over the cut pin. But then why the pin is cut here? Is it to make it act differently when it's outside of the chassis? Maybe when it's connected to some testing alignment equipment, it's meant to act differently than in the oscilloscope, I don't know. Why would anybody cut this pin, which the chassis actually bridges anyway? Now let's test it to see the effect of all the operations. It's a bit stupid to do multiple operations without testing it in between, because if you mess up, you don't know which operation did it. But this is so complex, it's impossible to reassemble it, to test it after changing each individual capacitor. Okay, apparently at least I didn't make it worse. Or if I turn it on with the color filter disconnected. Black and white picture again, but without the weird color effect at the beginning. I guess it initially gets some pulse, causing this weird dissolving color effect, and then there is just no voltage on it anymore. And looking through this gap, I guess the CRT itself is way brighter than it looks through the inactive filter, which makes sense. The filter has to pass at most 1/3 of the light in an ideal situation, but in reality way less than this, I guess. So removing the filter will make it way brighter and save a lot of life of the CRT. Well, what if I just connect it to a function generator output? Each of the two stacked filters seem to have the blue common and the other 5 for the 5 stripes. It's split into 5 stripes to help to synchronize it with the CRT scan. I'm just giving it the signal from this function generator, connecting the second stripe of one layer and the third stripe of the other layer. Near 9 Hz I can actually see some interference pattern here between the CRT scan frequency and the function generator frequency. This is at just a couple hertz, close to 9 Hz. Reducing the voltage, increasing the voltage, reducing, increasing. It sort of does something, but also the colors greatly depend on the viewing angle. Square wave, sawtooth, sine wave. Sine wave actually seems to have the most effect on it. Now connecting two overlapping stripes. There is some interference pattern again. Higher frequency. Lower frequency. Now these rectangles are supposed to be colored. Now when I synchronize the frequency, they're sort of trying to be colorful. This is 30 Hz. 60 Hz. 90 Hz makes them all the same color. I guess 60 Hz should work. Square wave doesn't work much. Triangle wave or sawtooth sine wave. But of course with just one signal it would be sort of just two colors anyway. But it's also showing these weird patterns over it. I guess the liquid crystals are sort of rotten, dissolved now. It's trying to do something at least a little bit. But I think I had enough of it. Out goes the filter, let's make an autopsy of it. The thing has some black resin around it. Maybe some clear resin in between. And this should just come off now, hopefully, without imploding the CRT on myself. And that's it, basically. And this contains two layers. You can see two panels of glass here, and the two connections going to it. We can maybe do some separate experiments with this thing. It does something. And here's the bare CRT, which finally is quite bright. It's very nicely visible even under studio lights. This is white background. This is surely handy to wear the hell out of the CRT. This one is much better. Here I can basically switch between different brightness levels for normal use and for use under studio lights. And the brightness of individual things can be adjusted here. And of course activating some measurements here. And just a comparison how dim it would be with the filter. Bloody hell! I should probably clean and relubricate the fan, putting it back together, and you say these contain batteries like built in, not replaceable, and these are soldered in, no sockets? Who designed this? And the label of the fan. The fan seems to have balls, ball bearings, and a temperature control with a sensing thermistor here. Some chips, some transistors, another transistor, even more transistors in it. Relubricated. Not sure how much I managed to spray into it, but I hope it's going to be less noisy now. A bit better. It's much quieter and doesn't have the post-apocalyptic sound to it anymore. Let's try to test it on a 433 MHz transmitter. The exact frequency should be 433.92 MHz. And the frequency seems to be quite close. Nice. Some FFT, this is the base frequency, and the second harmonic probably. And now all 4 channels in use. A 4-digit LED display multiplex. Super nice. A 4-channel oscilloscope with 4 probes. Super handy. It's working well. It might need some other work, like the built-in batteries. I might back up the data in the chips as some of you suggested, if I figure out how to do it. If I have more time, I can go back to this, of course, and try to make it work. I could actually take the CRT with its boards out, lay it on the top over something non-conductive, to be able to power it with the monitor board is accessible. Then I can do some measurements in it when it's running. The 5 pins going to the color shutter board are sort of a bottleneck here, so I can measure if there is some signal to synchronize the color shutter going into the color shutter board. And if there is some synchronization signal and some supply voltage going to the color shutter board, then something in the color shutter board is probably bad. And if it's not getting the synchronization signal or the supply voltage, the problem is probably somewhere else. But let's maybe leave it for another episode. When running the monitor board outside, you would also have to wire it to replace the interconnections the chassis makes. And also I'm hesitant to keep poking in it when it's already working, because there's always the chance of accidentally breaking something or shorting something. I might also decide to keep it as it is. I might also slide the CRT more to the front. Now without the filter there is a massive gap here. I might make another episode about this one, but most of you probably want to see something else now. And the video is getting bloody long, and if you made it that far, you're probably one of the few most loyal viewers. So please consider subscribing, supporting this channel on Patreon or using the thanks button. And big thanks to all of you who already support me, because this channel couldn't exist without you.